everyone, Morgan here. So we're going to be talking about doing the mathematics of a titration. Okay, this is page 11. We'll do another one on page 12 of the acids and bases outline. So this first one deals with the titration of vinegar. Vinegar, mostly water, plus some acetic acid. So we're going to be looking at how we can determine the amount of acetic acid that's present. The acetic acid will react with NaOH, that's hydroxide ion, in a 1-to-1 ratio to form water and acetate ion. Okay, so what we have is the mass of our empty Erlenmeyer flask, which is going to contain what we're analyzing. That's the acetic acid. We put some vinegar in there. It goes up to 99.00, so that's easy math there. Then we titrate it until the endpoint is indicated by our indicator. The burette initially was at 0.22 milliliters, and if you're writing down a volume with a burette and it doesn't go to 2 places after the decimal, it's automatically wrong. The final burette rating. Now, how do we figure out the milliliters of NaOH added? Well, that's pretty simple. All we've got to do here is take the 14.61, the final volume, minus 0.22, which is the initial volume, and we get 14.39 milliliters. The molarity of that NaOH has to be known because it's the titrant. The liters of the NaOH, we just have to divide that by 1,000, 0.01439 liters. And we want to get it to liters because the molarity is in moles per liter. So we can just multiply those two together now. Moles equals molarity times volume. So 0.2315 times 0.01439, and that gives me 0.003333 moles of NaOH. Now, we already identified up here that it's a 1-to-1 ratio in this reaction, so the moles of NaOH must equal the moles of acetic acid in the vinegar, 0.003333 moles. Now remember, those leading zeros are not significant. So I can take that number and multiply by the molar mass of vinegar, okay, which should be about 60. Let's add it up here. So I got 2 carbons, 12.01 times 2, plus 4 hydrogens, so 4.04 total, plus 2 oxygens, which is 32, so 60.06. Multiply that by 60.06 grams per mole times 0.003333, and I get 0.2002, let's call it, grams. Now that's the acetic acid in the vinegar, but the vinegar has a much larger mass. We see that it's 4.00 grams. That's 99.00 minus 95.00. So to figure out the percentage, I take 0.2002 grams of the acetic acid, divide by the 4.00 grams times 100%, and that is going to be, if I'm doing this in my head right, 5.00%. Let's check that. 0.2002 divided by 4 times 100, and yeah, 5.0. That's a 5 out there, so we might round it as 5.01%. Okay. There you go. That's the basic arithmetic behind how to do a titration problem. We'll take a look at another one on the next page. All right, so here's the next page. This one deals with ammonia, which is a household cleaner. So we're going to titrate it with HCl. It'll still be a 1-to-1 ratio. My milliliters added, okay, will be 65.46 minus 0.25, and that gives me 65.21 milliliters. Divide that by 1,000, 0.06521. Now we're going to multiply the molarity times the volume. So divide that by 1,000. There we go. Multiplied by 0.4500, and I get, let's try that again, 0.0625, or 0.06521 times 0.4500, decimal one in that time, good, 0.02934. Moles. Now, we know it's a 1-to-1 ratio still. That's all we're going to do here in Honors Chem. It's nice 1-to-1 ratios. Moles of ammonia that are in the cleaner. We multiply that by the molar mass, which was actually given up here, which is 17.04 grams per mole. And that, comes out to be exactly 0.500 grams. Now, when I look up here, the empty flask and the cleaner, that's a difference of 5.00. So now I have 0.5 divided by 5.00 times 100%, or that comes out to be 10.0%. All right, there you go. And your lab calculations are pretty much going to look exactly the same as that. Thanks for tuning in. Have a good day. This is Morgan signing off.